Ranked bonds, most polar to least polar. Had to be careful, right, where the numbers are. Folks got a little confused when a nitrogen is bonded to a nitrogen, or when any atom is bonded to another similar atom. That's not going to be polar, right, because they're equally the same, right? So the most polar atom, electronegative atom, will be fluorine, and then carbon, because nitrogen is just like basically a wash, so that's not very polar at all. And so basically you're looking at between carbon and fluorine is much more electronegative, farther to the right on the periodic table, so that's the one. Number 2, draw Lewis dot structures. Make sure lone pairs, formal charges. Those are big things folks forgot. This was something we similarly worked on in class. We actually worked on HNO3 in class. Again, put the nitrogen in the middle, put the oxygens around it. H's usually are not bonded to the central atom. So formal charges, lone pairs, recognizing nitrogen with 4 bonds has a plus charge. And there's still an overall plus charge for this molecule, so you gotta make sure you have a plus charge there. And then filling in your lone pairs and all that good stuff that we need to do. For number 3, what hybrid orbital are lone pairs located in? Again, this is asking, do you know the hybridization state of this oxygen? So the hybridization state of that oxygen is sp2 hybridized because it has 1 pi bond, which means it has a p orbital, an sp2, an sp2, and an sp2 hybrid orbitals. So the lone pair is actually in an sp2 hybrid orbital. So is this lone pair actually too. So knowing those hybridization states, those hybrid orbitals. Hybridization state of the starred atom. Some folks forgot to do this. You don't forget to read these questions carefully. Has no pi bonds, so it's sp3 hybridized. All right, here, so assign the hybridization state. Again, the boxed in means the hybridization state. This carbon is sp2 hybridized. Now I say these are, for as far as you know right now, these are sp3 hybridized. So some of you might have looked at the quizzes from 2019, and I had done things a little differently then. So you always got to be careful about how you do things. So as far as you know, these are still sp3 hybridized, which is fine. Right? I was careful to avoid tricky situations like that. But if you're looking at different years are different years. So sometimes things are taught differently, things are told differently. So but these are sp3 hybridized because as far as you know, they have no pi bonds. This one has 1 pi bond, so it's sp2 hybridized. One of the hybrid orbitals for sp, so you need to draw these out in the correct shapes, right? You need to see that like kind of 8 for the p orbitals in the shading, a little more S-like character for the sp orbitals. But needed those shapes and needed that shading. Wasn't looking for that 3-dimensional picture. Some people did that, which is cool, but you didn't need to do that. Looking for the molecular formula here. Just be able to recognize these hidden hydrogens. That's the key. If you see a carbon and it doesn't have 4 bonds that you can see, you just assume whatever's left over is bonded to a hydrogen. So being able to recognize those things was a big deal. Recognizing, again, what was sp2 hybridized as far as you know. A lot of folks forgot these oxygens, or they forgot the carbon bonded to the carbon, the double bond of oxygen, or they missed some of these along the way. There's at least 18 total. There were sp2 hybridized, 16 carbons, and 2 oxygens as well. And then, getting the lone pairs in and that kind of good stuff. Right? Really remembering and thinking about hybridization state, where the hydrogens are at, all those kind of things, lone pairs, how many bonds things want to have, all that good stuff. It's a different way of looking at it, but we got to practice that. For this one, again, challenging question, but again, you're given the starting materials, you're given the products. You need to draw arrows to show the bonds being broken, the bonds being formed. So this is an elimination reaction. Right, we're making a pi bond, so now you know that. You didn't know it then. Mechanism arrows, right? Mechanism arrows are just curved arrows. They're just like resonance arrows, except they're used for reactions. Resonance arrows are used for resonance, but they look the same, right? You show an arrow moving 2 electrons, that's a double-headed arrow. So you needed to make a new OH bond, you needed to break a carbon-bromine bond, and it looks like you need to make another new pi bond between the 2 carbons. So show arrows making that happen, right? Oxygen grabbing the hydrogen, forming a new OH bond, that's what that lone pair does. These 2 electrons in that CH bond going here to form that new pi bond. The carbon-bromine sigma bond breaking, those 2 electrons go into bromine. Now the bromine has the negative charge. So balancing your charges, of course, are the most important things to do as well.